Hello everyone, welcome to the Mathematics in my channel. In this video, we are going to solve another interesting integral from 0 to 1, natural log of x times natural log of minus natural log of x over 1 minus x dx. Well, I am going to begin with your substitution. So we can take x is equal to e to the minus t. Then if we differentiate, dx is equal to minus e to the minus t dt. Also, if we take natural log both sides here, we have t is equal to minus natural log of x. Okay, then we can plug in here. Now we should change the limit. Lower limit when x approaches to 0. Here we have infinity. Upper limit 0. Now natural log of x, we know natural log of x is equal to minus t. So we have minus t times natural log of minus natural log of x. Again we have t. So here t over 1 minus x. So 1 minus x we know e to the minus t, and dx is equal to minus e to the minus t dt. Okay, then we know this minus sign get cancelled, will be plus. So we can take minus sign as a factor. Then we can change the upper limit and lower limit 0 to infinity. So we have t times natural log of t times e to the minus t over 1 minus e to the minus t dt. Okay, then here minus integral from 0 to infinity t times natural log of t times e to the minus t. Then we have 1 over 1 minus e to the minus t. So we can use the geometric series. So we have sum of n is equal 0 to infinity e to the minus nt dt. Well, then here e to the minus t, here e to the minus nt. So we can simplify. So minus 0 to infinity, here t times natural log of t times sum of 0 to infinity. Then we can take e to the minus t as a common factor. So here n plus 1 dt. Okay, then as a next step, I am going to set the index t times natural log of t. Then here we have sum of 0 to infinity. So I am going to take n is equal 1 to infinity. So here we have e to the minus nt dt. Okay, let's interchange integral sign and sigma notation. So we have minus sum of n is equal 1 to infinity, integral from 0 to infinity t times natural log of t times e to the minus n times t dt. Okay, now what can we do? Okay, now we are in the most beautiful step, because this integral, we know the Laplace transform. So we know the definition of Laplace transform. Laplace transform of f of t is equal to integral from 0 to infinity e to the minus st times f of t dt. So we can write this is equal to minus sum of n is equal 1 to infinity Laplace transform of t times natural log of t here in dt. Okay, now how to find the Laplace transform of t times natural log of t? Well, don't worry, we evaluated this question, Laplace transform. So in a previous video we discussed about Laplace transform of t to the m times natural log of t. Here we have gamma of m plus 1 over s to the m plus 1 times digamma of m plus 1 minus natural log of s. If you like to watch this video, I will add the link in the description and also make a card. So when m is equal to 1, we have Laplace transform of t times natural log of t. So here I am going to take in. So we have here gamma of 2 over n to the 2 power times digamma of 2 minus natural log of n. Okay, gamma of 2 we know 1, so 1. Here digamma of 2 here n square. Digamma of 2 we know 1 minus gamma. We also discussed about the integer value of digamma function in the previous video, so you can watch by searching digamma function videos. So here minus natural log of n. Okay, this is the Laplace transform of t times natural log of t. Then we can plug in. Now here we have minus n is equal 1 to infinity. So minus sum of n is equal 1 to infinity. Laplace transform of t times natural log of t. So we have 1 minus gamma minus natural log of n over n square. Okay, then I am going to take minus sign as a factor. So n is equal 1 to infinity. Then we have gamma minus 1 plus natural log of n over n square. Okay, then we can split this infinite sum into two different sums. So here gamma minus 1 we know we can take outside of the sigma notation, and here we have n is equal 1 to infinity 1 over n square plus sum of n is equal 1 to infinity natural log of n over n square. Well, then we know here this is equal to theta of 2, but how to evaluate this infinite sum? As I remember, 2-3 times we solved this infinite sum. So let's evaluate here. First let's call the theta function, Riemann theta function. We know theta of s is equal to infinite sum n is equal 1 to infinity 1 over n to the s. Then if we differentiate with respect to s, we have theta dash of s is equal to n is equal 1 to infinity minus 1 over n to the s times natural log of s. So we have minus. Now when n is equal 1, we have natural log of 1 we know 0. So this series we can begin with 2. So n is equal to infinity natural log of s over n to the s. So we have here gamma minus 1 times, this is we know theta of 2. Then this is equal to we know minus theta dash of 2. Theta dash of 2. So minus theta dash of 2. Okay, then we know another relation between theta 2 and theta dash of 2. We know theta dash of 2 is equal to gamma plus natural log of 2 times pi minus 12 times natural log of a. Here capital A we know Glaser-Clenkening constant, and here theta of 2. So we can plug in. So we have here gamma minus 1 theta of 2 minus theta dash of 2. We know this is equal to gamma plus natural log of 2 times pi 12 times natural log of a times theta of 2. Then we can take theta of 2 as a common factor. So here we have gamma minus 1 minus gamma minus natural log of 2 pi plus 12 times natural log of a. So if we simplify, we know gamma get cancelled. So we have theta of 2 times 12 times natural log of a minus natural log of 2 times pi minus 1. Okay, this is the answer for this integral. If you like this type of videos, please subscribe this channel. Thank you for watching.